6th grade, Module 5, Lesson 7, Classwork. Determine the lengths of the given segments by determining the distance between the two endpoints. Okay, so here we're going to be working to find the distance between two endpoints and using absolute value expressions and equations to prove those distances. So let's start with AB, so line segment AB. I'm going to go down here. So here's line segment AB on the diagram. So the point for A is at, here's 0, 0. So A is at -2, and then we have to go up, that's 8. So A is at -2, 8. And B is at, let's see, 1, 2, 9, 8. And I don't need to count up because if A was at 8, then B is also at 8 because they are parallel. So 9, 8. So now the distance between those two, what it means by distance is how far is it from A to B, or how many units. So 1, 2, 3, 4, 5, 6, 7, 8, 10, 11. So the distance is 11. Now we don't always want to have to count. So what we can do is use expressions and equations to and absolute value to find the distance. So when I'm looking at my points, I'm looking for what is different. So they both have an 8. So I don't really need to do anything with that because they're equal. Where they differ here is the x coordinate. So we want to find the difference between the x coordinates and use that will show us our distance. So something to note is that if the coordinates are on opposite sides of 0, we're going to add. So I'm just going to write a little note up here. So if it's on the opposite side of 0, we add. If they are on the same side of 0, then we're going to subtract. So what I mean by that is looking at AB. So A, this is 0 right here. A is on one side of 0, B is on the other side of 0. So they are on opposite sides of 0, meaning I'm going to add. So let's find the absolute value of -2, and then they're on opposite sides of 0, plus the absolute value of 9 is equal to, remember the absolute value, we're just finding the positive value of it. So the opposite value of -2 is 2, absolute value of 9 is 9, so 2 plus 9 is equal to 11, or our distance, which is just proving that our distance is 11. Okay, let's do BC. All right, so BC is right here. So B is going to be at, this is 9, 1, 2, 3, 4, 5, 6, 9, 8, which we already knew from the last problem. And C is at 9, 2. Now I'll find the distance by doing the proof. So what I notice is that BC, they're both on the same side of 0. So here's 0. They're both above 0. They're both positive. So in this case, I'm going to be subtracting their absolute values. So let's find the coordinates that are different. X coordinates are the same, so we're going to do the absolute value of 8 minus the absolute value of 2 is equal to 8 minus 2 is 6. So the distance would be 6. And we could also have gotten that by just counting. So 1, 2, 3, 4, 5, 6. The distance is 6. But this is useful because when we're getting into coordinate grids that we're using very large numbers, you're not going to want to count, right? You're going to want to be able to use an equation. So let's do CD. So CD is right here. Let's find, so C is 9, 2. And D is located at 9, 1, 2, 3, 4, negative 5. Now they are located, here's 0, on opposite sides of 0. So that means we are going to be adding. So find the x values are the same, the y's are different. So let's do the absolute value of 2 plus the absolute value of negative 5 would be equal to 2 plus 5, so the distance is 7. All right, BD. So BD is all the way up here, down to here. They're on opposite sides of 0, meaning we're going to be adding. So the coordinates for B were 9, 8. And for D, they were 9, negative 5. So we're going to be adding the y coordinates because those are the difference, the ones that are different. So let's do the absolute value of 8 plus the absolute value of negative 5 would be equal to 8 plus 5 is 13. So the distance is 13. All right, DE. So here we have DE. So the coordinate for D is 9, negative 5. And E is, let's see, negative 2. And then 1, 2, 3, 4, 5. Negative 2, negative 5. Okay, so DE are on opposite sides of 0. So here's 0. They're on opposite sides of 0, so again, we're going to be adding. And in this case, the x coordinates are the coordinates that are different. So let's add the absolute value of 9 plus the absolute value of negative 2. 9 plus 2 is 11, so the distance is 11. All right, EF. So we have already found E. E was negative 2, negative 5. And let's find EF here. So here's EF. So F is at negative 2, negative 2. Now these coordinates are on the same side of 0. So here's 0. They lie on the same side of 0. So we're going to be subtracting the coordinates that are different. So they have different y coordinates. So let's find the absolute value of negative 5 minus the absolute value of negative 2. 5 minus 2 is 3. So the distance is 3, which we can also see. 1, 2, 3. There's the distance. FG. There's FG right there. So the coordinate for F was negative 2, negative 2. And the coordinates for G are 2, 1, 2, 3, 4, 5, 6. So negative 2, 6. Now, they are on opposite sides of 0, so we're going to be adding them together. So we have the absolute value. Which ones are different? The y coordinate. So the absolute value of negative 2 plus the absolute value of 6 is equal to 8. The distance between those coordinates is 8. EG. So the G stays the same. So that's still negative 2, 6. Let's look for EG. So E all the way up to G there. And the coordinate for G for E was right here, -2, -5. So they are on opposite sides of 0. There's 0 right there. They're on opposite sides, so we're going to be adding them. And they are different. Their y's are different. So let's do -5 plus the absolute value of 6. 5 plus 6 is 11. So their distance is 11. All right, GA. Here's GA. So the coordinate for G was -2, 6. And the coordinate for A is -2, 8. Now these lie on the same side of 0. Right? They don't cross 0 at any point. So we are going to subtract their differing coordinates, which in this case is the y. So we're going to do the absolute value of 6 minus the absolute value of 8. And then our answer is also going to be an absolute value. So 6 minus 8 is -2, but the distance is 2. So that is equal, the distance is 2. FA. Let's find a color I can draw over these. So FA is right there. Okay, so F was -2, -2. And A was -2, 8. And they are on opposite sides of 0, so I'm going to be adding them. And here the difference is 2 and 8. So let's do the absolute value of -2. Whoops. It's hard to read. Plus the absolute value of 8. 2 plus 8 is 10, so the difference is 10. And the last one, EA. Okay, here's E, here's A. So we're doing this whole line segment. The coordinates for E were -2, -5. And the coordinates for A were -2, 8. You can see they're on opposite sides of 0. There's 0. A is up here, E's down there. So we're going to be adding. They are different in their y coordinates. We have the absolute value of -5 plus the absolute value of 8. 5 plus 8 is 13. Okay, so now we just have another one. Complete the table using the diagram on the coordinate plane. So we're just going to do the same thing with a whole nother diagram. All right, BI. So here's B, there's I. So B, let's find 0. There's the X and the Y coordinate. So B is located at -2, 3. And I is located at -2, 0. And we are going, remember, if they're on opposite sides of 0, we add. I'll write it over here again. Opposite means we add. Same means we subtract. So here, they are not on opposite sides of 0. They are actually on the same 0, just because it's on the same side. So we're going to subtract. So let's do, they differ in the y coordinate. Let's do the absolute value of 3 minus the absolute value of 0 will be equal to 3. And actually you could add or subtract because you'd still get 3. But I just chose to subtract. So BH, the point for B is -2, 3. And H right here would be -2, -1, 2, 3, 4. So BH, these are located on opposite sides of 0, which means we're going to add. And they're different in their y coordinates. So absolute value of 3 plus the absolute value of -4 will be equal to 7. So their distance is 7. BE, so again, B is -2, 3. E is down here. We're doing B, E. E is located at -2, -1, 2, 3, 4, 5, 6, 7, 8, 9. And BE are on opposite sides of 0. There's 0. They're on opposite sides, which means we're adding. So absolute value of 3 plus absolute value of -9. 3 plus 9 is 12. So their distance is 12. GH. Okay, look for GH is right here. GH. So the coordinate for G would be -1, 2, 3, 4, 5, 6, 7, 8, 9. And then -1, 2, 3, 4. So -9, -4. And I've already found H. H was right here. So the second one, -2, -4. And let's look at GH. Are they on opposite sides of 0 or the same? They are on the same side, because here's where they would cross 0. It does not cross. So they are on the same side, meaning we're going to subtract. So absolute value of -9 minus the absolute value of -2. 9 minus 2 is 7. Their distance is 7. HC. Here's H. Here's C. Okay, H was located at -2, -4. C is located at 1, 2, 3, 4, 5, 6, 7, 8, -1, 2, 3, 4. So 8, -4. HC are on opposite sides of 0. So here's 0. They cross 0. So we're going to add the absolute value of -2 plus the absolute value of 8 equal to 10. All right, GC. So here's G all the way over here. Here's C. So G was -9, -4. C was 8, -4. They do cross 0, so we're going to add the absolute value of -9 plus the absolute value of 8. 9 plus 8 is 17. Their distance is 17. CD. So I know C was right here, 8, -4. And D doesn't look like we've found D yet. So C, here's D right there. D is at positive 1, 2, 3, 4, 5, 6, 7, 8. And then -1, 2, 3, 4, 5, 6, 7, 8, 9. -9. Okay, CD. Does it cross 0? It does not. So that means that we are going to be subtracting. So let's find the absolute value of -4 minus the absolute value of -9. And we get -5. Since it's negative, we're trying to find the distance. So we'll just take the absolute value of that. So the distance is 5. And FG. Okay, where's F? Here's F. Here's G. So F is located at, let's see, there's 0, -1, 2, 3, 4, 5, 6, 7, 8, 9. And then all the way down to -9. So -9, -9. And then G, we've already found before, It was right there, the first one, -9, -4. So FG does not cross 0, so we are going to subtract their absolute values. So we have the absolute value of -9 minus the absolute value of -4 is equal to 5. So their distance is also 5. GA. So G was -9, -4. A, have we found A yet? I don't see an A. Okay, so G, A, they cross 0, so we're going to be adding. A is at -9, 1, 2, 3, 4, 5, 6, 7, 8. -9, 8. And we're going to be adding. They differ in the y coordinate. So -4 absolute value plus the absolute value of 8 would be equal to 12. And then the last one, AF. So A was -9, 8. F was right here, -9, -9. Let's look at AF. Does it cross 0? So here's A, F, and it does, because there's 0 right there. So we're going to be adding absolute value of 8 plus the absolute value of -9 is equal to 17. All right, extension. For each problem below, write the coordinates of 2 points that are 5 units apart with the segment connecting these points having the following characteristics. All right, so I'm just going to draw my own coordinate. The segment is vertical. So there are many different choices that you could have here. So if you want your segment to be vertical, meaning up and down, and we want them to be 5 units apart. So I want the distance to be 5. So if I made this, doesn't matter what the x coordinate is. Make it maybe 4 and then 3. Then I need it to be 5 down. So 1, 2, 3, 4, 5. What would that make this one? That would make it 4, -2. So there's one. That would work. And one way to prove that is where they differ is the y coordinates, the absolute value of 3. They're on different sides of 0, so we're adding plus the absolute value of -2 is equal to 5. Segment intersects the x-axis. So the one I just drew, here's the x-axis right here, works, and they are 5 units apart. So I'm just going to use that one. 4, 3, and 4, -2. We've already proved that the distance is 5. Segment intersects the y-axis. So here's the y-axis. So let's draw one. Let's see. If I made my point here, and then distance over here, 5 more. Let's say this is 5, -3, and actually let's make it -2. Doesn't matter, just how I drew it makes it look more like -2. So then we would need to go over to 5, 3 in order to make the distance 5. So we have 5, -2, and 5, 3. And we can prove that that works because the absolute value of -2 plus the absolute value of 3 is equal to 5. And D, the segment is vertical and lies above the x-axis. So it's vertical and it's above the x-axis. So something like this. So let's say this is -8, 7. If we want it to be 5 units down, we're going to need to subtract 5 which would get negative 8, 2. So negative 8, 7, negative 8, 2. We can prove those are 5 units apart by doing the absolute value of 7. They're on the same side of the axis, minus the absolute value of 2, which means, so we subtract. So that's equal to 5. And again, you can have completely different answers that I have A through D. There's many, many, many possible solutions. As long as they follow the criteria, you're good to go.